Alright, question number 6. Okay, let's see. Prove that cotangent x over 2 minus tangent x over 2 equals to 2 cotangent x. Okay, so first we always start with the left hand side, because we always start with the more complex side and then we try to simplify it. Okay, because it's harder for you to expand compared to simplifying. So we always start from the left hand side. So question A, left hand side is what? Cotangent x over 2 minus tangent x over 2. So you want to make this become 2 tangent x. So what we're going to do is, I think you all notice, right? Here is cotangent, here tangent, here cotangent. So what does that mean? It means I can change everything in terms of tangent, correct? So that is easier for me to navigate this, how to simplify it. Okay, we can change everything to tangent. You can also do sine cos, okay, but it's good, you're going to break it down even more. So I think you don't have to do that. We can just stick with tangent. Okay, so we are going towards here, right? So 2 tangent x, 2 cotangent x. So 2 cotangent x is actually also equals to what? 2 over tangent x, right? Because cotangent is 1 over tangent, right? So 2 over tangent x. So what do you notice from here? You notice that here is x over 2 and then here is x. So that means we want to use the half angle formula. Okay, the half angle formula. So okay, I'm going to write like this: 2 and then 1 over tangent x. Okay, so half angle formula is what? We know that the half angle formula is like this: tangent x equals to 2 tangent x over 2 over 1 minus tangent square x over 2. Okay, now but here what you have is 1 over tangent. So if I change this to 1 over tangent, then these two have to flip, correct? So what I will get is something like this. I will get 2 on top here, the 2 will come up here. So I'm going to write 2 and then this will be up, so it will be 1 minus tangent square x over 2 over 2 tangent x over 2. Okay, so this part here comes down and then this one comes on top and then the 2 is here lah. Okay, I hope I'm not confusing you. Why I'm doing this part is so that later we know that we are doing this, we are simplifying to make it become this form. Okay, when we can make it become this form, then we can reverse to find the... Okay, if you find this complicated, then you just do your way lah. Okay, I'm just showing you how I usually approach this. Okay, so this one is all, I said we make it all in terms of tangent, right? So this one become 1 over tangent x over 2 minus tangent x over 2. So I'm going to make them become the same denominator. So here become 1 over tangent x over 2 minus, here will become tangent square x over 2 over tangent x over 2. Okay, so I can combine them. So I get 1 minus tangent square x over 2 over tangent x over 2. So what do you notice? You notice that, you see this part is actually the same as here. This part. Right? 1 minus tangent square x over 2 over tangent x over 2. So the only difference is got 2 and 2 up there, right? Correct? So what I'm going to do is I'm going to times 2 up here, times 2 up here. Okay, so what I get is, okay, let me scroll down. Okay, so what I will get is 2 1 minus tangent square x over 2 over tangent x over 2. 2 tangent x over 2. So this one will give you what? This one will give you 1 over tangent, right? 1 over tangent. Correct? I hope it's not confusing. Okay, anyway, so I'm gonna get this part here is gonna become 1 over tangent x over 2. So 1 over tangent is cotangent. Sorry, x. What am I writing? This is not x over 2, this is x. So it's 1 over tangent x. Okay, yeah, basically that's how you do it. Okay, next. By the way, if you find this complicated, you can either do it your way, or you can just type in a comment, then I'll try to explain better. Okay, alright, let's see question B. Hence, sketch. Okay, they ask you to sketch this graph here. Okay, so we have question B2. Y equals to 1, sorry, not 1, modulus x, what am I talking? Cotangent x over 2 minus 2 cotangent x. So what we can see is actually a rearrange of this, right? We actually rearrange. So we can actually change, oh sorry, here got minus 1. So this part, if you rearrange this, it becomes what? Becomes modulus tangent x over 2 minus 1, right? Okay, in case you can't see it, I write here lah. So cotangent x over 2 minus 2 cotangent x equals to tangent x over 2. Okay, so yeah, I just write this into this part. Okay, so now we can sketch. This is much easier to sketch, right? So first thing, we are sketching what? X over 2, right? Tangent x over 2. We know that tangent x is how? If I ask for tangent x graph is like this, right? We know it's like this, something like this lah. Okay, here's the asymptote. Okay, but now you are only drawing what? X over 2. That means half a cycle only. It's not a full cycle. This is a full cycle, but you only want half a cycle. So that means you only want this part, half of it. Okay, so we're not going to draw this part, just this and this. Clear? So let me erase this. Okay, so we have, where should you use red? Okay, so we have this part, and there's the asymptote. Here is the second part. Okay, but what you notice is there is modulus. Modulus means what? All the negative part is going to change into positive. So this one is going to come here. Okay, so wait, label first. So this is 2 pi, this is pi. Okay, this is x, this is y. Okay, now minus 1 means the whole graph have to shift by 1 unit down because negative. Okay, so shift down by 1 unit. So your new graph is going to become like this. So your here is negative 1, let's say. So this is your graph, something like this lah. Okay, so this will be 2 pi. Here is the asymptote, right, just now. So here is pi, here is y, here is x. Okay, so yeah, your graph looks something like this. Okay, now the last question, what they're asking, there is no solution obtained. There is no solution obtained if y equals to m. So y equals to m, you know the line is going to be a flat line, right? It's going to be a flat line like this, but we don't know where it is. Okay, but it says that there is no solution. No solution means what? That means it doesn't cross the graph at all. No solution, never cross at all, no intersection. So what does that mean? It means the line is going to be below this, right? Because if I put the line here, it will still touch the graph, which is what? That means there is intersection. We don't want that. We want no solution, no intersection. So that means it's going to be below here. Okay, so the question asks, state the range of value of m. So m should be what? So m will be less than -1, correct? Because it has to be below here. Otherwise it will cut the line. There will be solution. So we want no solution means m is less than -1.